Okay, so today I'll be solving Leetcode daily problem 3583 count special triplets. So nums I is equal nums j multiplied by 2 and nums k is equal nums j multiplied by 2. So what I want to do is kind of find, like the brute force solution would be do the brute force solution. Let's say this array 6. Oh. Close this. Open. So 6, 3, 6. This is too small actually. Let's make have a bigger. Okay, this one is too trivial. This one is probably better. 8, 4, 2, 8, 4. And then I'm trying to, like, the brute force solution would be to have all 3 pairs, and then I somehow, like, I go for every I from, like, I'll treat this I as a middle one. So I'll have I here, and then I go left and I go right. And then if I find any pair that can be, that's, so I need to find 8 in this case because it's 4. 4 multiplied by 2 gonna be 8, and I need to count number of 8s to the left and to the right. So to the left it's going to be 1, and to the right it's going to be also 1. And then the final number going to be left multiplied by right. So this one going to be 1 pair here, and then I move the pointer here, and then I do the same for the 2. I go left and go right, and I need to find 4. So here also 1, and then for the 8, move pointer. For the 8, I cannot find anything to the left and to the right, and that's it. So the answer should be 2. Is it 2? Yes. So because this length can be like quite long, it can be up to the 10 to the power of 5. I need to optimize this going back and forth, and the nums actually also. So length is 10 to the power of 5, and then the num itself also 10 to the power of 5. So I need to somehow optimize this going back and forth, because if I do that for every number that's supposed to be center, so it's going to be n minus 2 numbers, and it's like roughly n, and I need to go left, whatever, like let's say you have I need to go left I minus 1 and check if I can find the num I multiplied by 2 number, and then I need to go to the right, and it's going to be plus n minus 1. Let's say we have here 5, and then I2, So it's gonna be n minus I, and it's gonna be just n minus 1, this one and this one, and it's gonna be of n squared. So the time complexity of this brute force algorithm gonna be of n squared, and the space complexity gonna be of 1, because I'm just gonna go left and right, and this time gonna be of n squared. So the question is how I can improve it, because like currently it's gonna be out of the time limit exceeded, and I need to figure out how I can improve it, and maybe like use some better space, and I assume I can somehow move it to this of n space, and then time gonna be of n time. So what I think is, if I just have a frequency counter for the numbers, and then those numbers can be max 10 to the power of 5. So let's say I have frequency counter, and then let's say I have 8 actually, 2, there are 2 8s, and there are 4, and there are 2 4s, and there is 1 2, and then for every number, I need also to do that dynamically, because I need to know what's on the left and what's on the right. So I changed it a little bit, so I've built up this up to the n. So I built one map for the map of, let's say, left, and it's gonna be for indexes 0 and then I minus 1, and then gonna be map right, it's gonna be for indexes I plus 1, and then n minus 1, and initially I'm gonna create map right and map left, and map right gonna have n minus 2 elements, and then map left, so initial is gonna be initial size of this one of map right gonna be n minus 2, and the size of map left gonna be just 1, and then I need to find like for the current pointer at 4, I'm gonna start iterating I from 1 up to the n minus 2, and then for the current pointer I need to figure out what's the number there, multiply it by 2, so like 4 multiplied by 2 equals 8, and then I need to find the frequency of 8 in the left map and in the right map, and then I found it, and I multiply one frequency from the left and frequency from the right by each other and add it to accumulator, and then I move the pointer to the right, and I need modify map left and map right, so I keep the invariant, so I need to add 4 to map left, it's like constant operation of 1, and then I need to remove 2 from map right, and that's gonna be also of 1 operation. Yeah, sorry for my handwriting. but in this case, the time complexity of this algorithm gonna be of n, and then space complexity of this algorithm gonna be of n also. Vice time is gonna be of n, so I need to iterate over every element from array, from a given array, input array, except like the last and the first. And then on every iteration I need to also reconstruct the invariant for the map left and the map right by adding or removing values from those maps, and it should be of one operation. So total time complexity will be of n, and space complexity of n, because I need to store this map right and map left. So that's gonna be it. Let me check the time. Okay, so the time is 10 minutes already, so let me quickly code it. So I'll have this map left, map right equals directory, and then dictionary, and then map left equals this one, and then I'm gonna go so constraints are fine. There's the size of num starts from 3, so I shouldn't worry about it like being in 0. I'm gonna go for I in, so let's have this n equals len nums, and then for I in range n, and then if I is equal, that's ridiculous, so let's do that 1 up to n, and then map left equals, like put nums 0 equals 1, and then I wanna have just a counter, so I'm gonna map left, instead of this I wanna call it just counter for the slice, nums 0 and then 1, then counter for the slice, nums 2 and then 1, and then I'll do the end. And then I need to update the counter. Yeah, so I'm gonna go res is equal 0, and then for I in range 1, and then up to the, so I wanna have this overlapping. Up to n minus 1, and then here I want to as ABC here, and for the counter, so I want to have initially remove the and then re-add. So this one gonna be just counter empty array, and then here I wanna reconstruct the invariant, so I wanna put map left, then nums I minus 1 equals, or like plus equals 1, and then map right nums I minus equal 1, and then I want to have res plus equal then also mod here, mod is equal 10 to the power of 9 plus 7, then res is equal map left nums I multiplied by 2. So like search, let's say search equals nums I multiplied by 2. And then I want to search for this, say key, let's call key, and search for this key in the map left and multiply it by map right, and then also key. And then I wanna do this press plus and then mod, and then in the end I wanna return res. Something like this. Let me think about this one. Okay, let's run. Permit. Okay. So let's think about how we can improve this and if it's like improvable. Check the time. 16 minutes. Can I do better than off and space? It's not actually off and space, it's like off number of distinct nums. You can have probably the big vector list, so map left gonna be, let's say 0 0 multiplied by 10 to the power of 5 plus 1. The thing is here, and then map left. And then I need to go. What the error? Okay, so it should be like this. Concatenate list. I want to have a generator. Something like this. And then I want to go for I in range 1 up to n. Map right I. No, I wanna up to n. Yeah, map right nums I classical 1. So move it up. It's a tiny optimization, probably. Map left, map right, key. Oh, okay. If the key is key multiply k is greater than 10 to the power of 5 plus 1, or like 10 to the power of 5, then just continue. Let's run this test, use test, would work. Okay, submit. Yeah, it's a little bit better, but let's check what the people are doing here. Special default dictionary. So instead of doing this mod, they just return mod like this. Will it save some time? Yeah, it's a little bit better. So here, indices for the list. Okay, is there any editorial? Okay, binary search. That I have not thought about the binary search. Left count and right count. Yeah, it's not that better. Whatever. Let me stop recording.